Hello, everyone. So you probably noticed you're muted when you joined. That's just to avoid a lot of extra noise. So feel free to unmute yourself if you ever want to say anything. Where's the chat? Chat. Okay. I'm glad that you like the photo. He is the real thing comes to class sometimes. So he might photobomb. Actually, this one probably won't photobomb. Probably the other one will. But yeah, he's going to show up because he can. Oh boy. Cat hair. And as you all are joining, we will start right at 2. And it's also totally okay, as I was saying, to unmute yourself if you want to say something. We'll get there in a second. Is this anyone's first class of the semester? No. So I guess that it's also not anyone's. Sorry. Someone say something? Oh, someone's third. So I guess if this is nobody's first class of the semester, it's probably nobody's first class at CSUN, but definitely there have been times where I've taught this and it's been a morning class and it's been someone's like first ever CSUN class. Oh, it is your first, awesome. And again, it is okay to unmute if you so desire. It is letting you, right? I didn't accidentally screw that up, did I? Yeah, you can unmute yourselves. Okay. It's my first class of the semester.
How's your day going, Professor?
It's going pretty well. I've been again. I'm still in Northridge. I don't know how many of you are. It's really hot, but I've been just kind of taking it easy and getting in the right mindset to lecture. It's definitely the faculty just as much as the students were kind of like, oh, okay, time has felt fake all summer. We got to sort of make time be real again. But It's the one thing that to be said for suddenly everything is scheduled again is maybe time will feel less fake. But it's 2020, so who freaking knows? Anyway, so it is 2 o'clock. I'm going to give people a couple more minutes to trickle in, just because I know Zoom was having some like catastrophic outages earlier today. So I've been checking their Twitter, and they're pretty on top of saying what's going on. But I'm just going to give people a minute to connect. Normally we will start right on time, just because, again, everyone has so much to do online and so many things. I don't want to be using more of your time than is really allocated for this. But today I'll give people a couple more minutes. I see the number of people joining going up. So so cool. Give another minute or two. So again, if you were not here for Geology 101, you were in the wrong place, but I imagine that issue of showing up in the wrong classroom is less of a thing with Zoom. But yeah, as you all are coming in, you're going to start muted, and that's just because I know there can be issues with background noise and with echoing and with all sorts of things. But feel free to unmute yourself at any time if you have a question or a comment. Like, I think, we can all be, respectful of each other enough to not just yell over each other. I've never had that be a problem in class. So you don't need to, just go ahead and unmute yourself if you want to talk. If it does start to be kind of a lot of people talking at once, which would honestly be awesome. I would love to see really involved discussions like that. Then there is a little hand raise thing in Zoom. I can't see it in my participants window because I am the boss, I guess, but you should be able to click a little thing that says you're raising your hand. So if you want to say something and don't feel like just speaking up or typing it, feel free to do that. But yeah, the mute is just there to avoid like echoes and loud noises outside and siblings or roommates or cats screaming, any kinds of things. Cool. I guess we can start. I think the number of participants in that window has remained pretty consistent. So yeah, so let's get started. So this is Geology 101. This is Geology of Planet Earth. And I'm Dr. Lozos. I'm your professor, and I will introduce myself a little more later on. But first, we're just going to go through what is this class about. I mean, you notice the title isn't just Intro Geology. It's a much broader, like it's the planet. And so that might seem like a lot, and it is on the one hand kind of a lot, but I'm thinking we're going to set it up in a way that hopefully is manageable and ends up kind of feeling like we're telling a story about why the Earth is the way it is by the end of this class. So other than this picture of my cat, which we're starting with, and he might photobomb, but he might not. I have another cat who will definitely photobomb at some point, so I'm sorry about that. But we're really going to start with this geology class with something, if it'll let me advance the slide, there we go, with something you might expect to see in a geology class. So here we have a rock. And if we were in person, I would actually be passing this rock around so you could look at it and feel it and get a sense of what's going on. But as you might expect a geology class to start with a rock. So just what do you see about this rock? And again, feel free to either unmute or talk in the chat box.
It's a real cool rock.
Awesome. I happen to agree with that, and we'll talk about why a little later. But yeah, sometimes the observations you do can be really basic stuff. Like, what color is it? How big is it? What kind of texture do you see? It
looks a bit brittle.
Yeah. So this is something definitely, if I were passing this around, this rock's really brittle. It's actually really chalky. You would probably get a little bit of residue on your hands as you pass this thing around. but what else is going on here?
It has freckles.
Yeah, freckle. I like that description. I like that a lot. Yeah, so there's patches of different colors, freckles. I might keep using that. I like that. Yeah, so there's a lot of stuff going on here. What do you think those freckles might be? Just guess.
Maybe like another type of rock.
Yeah, actually, that's exactly what's going on here. Different colors, different shapes. Again, if you were actually passing this around, those spots are different colors. Can you see my mouse? Okay, yeah, so like especially the ones that are sort of smaller and darker are a lot harder than the rest. So something that at first pass might look like, yeah, that's kind of a gray rock. There's actually a lot going on here, and I'm already really excited that you noticed things like the freckles and the apparent texture, even without being able to touch it. And so that's certainly that kind of just attention to detail is a big part of geologic thinking. And sometimes it's when you're looking at a rock, and sometimes it's when you're looking at a whole landscape. A lot of geology is seeing the little details and using them to put together a big picture of what made the earth be like this. Why is this rock like this? Why is this here? Why is this landscape shaped like this? And so I start with a rock because, I mean, that's probably what a lot of people think of when they say Geology 101. But, well, maybe that is, maybe that isn't. Before I get ahead of myself, actually, what do you think geology is?
The study of rocks, or like, I would assume, but over time.
Yeah, rocks over time is definitely a part of it. I guess how many of you think of rocks first when someone says geology?
Pretty much always.
Yeah. So that's the pretty common conception, and I was expecting someone to say rocks first, but does anyone have any other thoughts of what geology is, what this topic encompasses? Do you really think we're going to spend an entire 12 weeks on 15 weeks, 12 weeks? No, we're 15. I went to a school that's on the quarter system. We're 15 weeks. So, man, I go right back to student brain myself when the semester starts sometimes. For 15 weeks, do you really think we're only going to talk about rocks?
No.
No, that's good. But they're a big part of the story. But the thing is, it is a story. It is not just rocks. Although, again, I wish I could be actually handing you rocks over the course of the semester. It is what it is. But yeah, so rocks, but also more than rocks. So if you look at our textbook, and we'll talk more about the textbook in a bit, it gives this definition, that geology is the study of the earth. Which is, I think, it seems like the most generic kind of cop-out definition. On the one hand, it's like, yeah. But on the other hand, looking at this extremely simple sentence that's in like the prologue of the textbook, when you step back and think about like, what does the earth encompass? Like, is the earth just rocks?
Oceans too.
Yeah, oceans and any other thing? Like what else?
Rivers, canyons,
Land,
caves.
trees.
Yeah, all of those things. Rivers, landscapes, ice. Technically, the atmosphere and the climate are part of geology, but there's a whole other class on that, so we're not actually going to touch that too much in here. But if you're interested in that, Science 111 is that class. But yeah, the Earth is many things. Rocks might be building blocks of it, but even then, rocks aren't the only thing in the earth. I mean, the ocean is obviously not a rock. The atmosphere, definitely not a rock. That would make some things very complicated for us. But the earth is more than rocks. And actually, the inside of the earth, as we're going to talk about next week, like there's molten metal in the middle of the earth. And if something is liquid, it can't be a rock. So even if you describe the earth as a rock, that's not entirely right. But yeah, the Earth in this context, it's a moving, changing, dynamic system. So even though on our day-to-day life, most of the time we don't see the Earth moving and changing, although what are some situations? I mean, we live in California where a lot of stuff happens a lot faster than in some other places. Like, what are some cases that you might think about in day-to-day life where the Earth is moving and changing in a way you actually notice it?
Fires.
Fires are definitely kind of an intersection of geology and ecology.
Earthquakes?
I heard someone say something extremely quietly.
Oh, earthquakes?
Oh yeah, very much. Yeah, so what happens every winter after it rains?
Floods?
Are you talking about the fires?
Spring.
Nose.
Spring, yeah. Yes, so we get the fires, and then it rains, and then what? You know how there's always mudslides? We'll talk about mudslides too. But yeah, there's stuff that's moving, and in California we can see it with fires that are following the landscape. So they're not necessarily caused by the Earth, but the shape of the Earth really controls where the fires can be. So this class, we're not really going to talk about fire that much, but there's a new class, Geology 117, where they will, and I think the geography department has some classes that have to do with fire. But things like earthquakes and mudslides and even erosion at the beach, like if there's a big storm and the tides carry in a lot of sand or out, that's all the Earth moving and changing on a time scale that we can see. But a lot of stuff also happens on time scales of hundreds or even millions of years. So sometimes the change doesn't seem like change because we can't see it, but it's very much there. And actually on Wednesday, a lot of our lecture is kind of going to be familiarizing ourselves with the many different timescales that you have to think about in terms of geology. But yeah, the Earth is far from static. It moves, it changes, it rearranges itself. And so geology is the study of that and of the physics and chemistry that drive it. Because really a lot of the processes on Earth are, a combination of physics and chemistry. And so, yeah, we're going to be talking about physics. We're going to be talking about chemistry. There's not going to be a lot of math in this class, but there will be some. There's going to be talk about forces. We're going to talk about atomic structures. So I think a lot of people have this impression that, and even a lot of people in other sciences are like, oh, geology is not a real science. All you do is look at rocks. It's like looking at rocks, depending on what kind they are. It's very much chemistry. It's very much physics. Fire is chemistry. Earthquakes are physics. So it's about these things, how the chemical structure of the Earth and the material structure of the Earth move and change and influence what the land we live on is and what we can get out of it. So we're going to be studying that movement, that change, that physics and chemistry, that history of our planet, and how it affects where we live now. So it really is kind of the biography of the Earth. It's not just here's an inert chunk of dirt. It is what made this be like that, and how does that affect where we are now? And so again, I'm hoping to frame this class in the context of helping you be able to tell that story of the Earth by learning some things about rocks. Oh yeah, I see someone said mudslides in the chat now. Sorry, I didn't see that, Brianna. Yeah, cool. So we all interact with geology already, like every day, whether or not we realize it. And it's not just, oh, I went outside and I got dirty because it hasn't rained and there's rock bits on my car. It's a much broader interaction. Some even things like just why is LA where LA is? Because the shape of the land allowed a big city to fit there. And that's geology. But there's other things like who all has anyone been here? Does everyone know where this is?
The Grand Canyon?
Yeah, so that's the Grand Canyon. I fully admit that I'm a very bad geoscientist because I have not been there yet. But have any of you been there?
Yeah.
Nice. So what did you notice? Like what did you see? What was, other than the fact that it is indeed very big, what kind of stood out to you?
Sort of like the lines, like kind of looks like layers and stuff.
Yeah, and so it doesn't just kind of look like layers. These actually are layers. So the Grand Canyon shows how layers and layers of rock have built up over millions of years. And because the Colorado River cut down really fast through all of this rock, basically don't mess with water, water beats rock. It's basically, this is kind of like a storybook of the history of this part of the earth, because all of these layers are exposed. So on the one hand, it's just amazing to go to this because it's beautiful, it's colorful, and it's just an enormous scale that makes you feel really small. It's also just, when you think about all of the things that have had to happen in sequence to make this exist, and we'll talk about that kind of in the third month of our class when we talk about sedimentary rocks in particular. But this is it's just an amazing chunk of history laid bare for the eye to see. What about this? Anyone been here?
Is that Yosemite?
Yeah, that is Yosemite. Have any of you been there? I see one yes from Brian.
Yeah.
So for those of you who haven't, this is like 4 hours from here. You should totally go once that's allowed. Again, I don't know if Yosemite is open. I know Sequoia is, but once national parks are open and safe to go to again, like, you gotta go here. It is really spectacular. It's like 3,000 feet from the base to the top of this, and it's just, so this thing, Half Dome, again, I mean, on the one hand, this is obviously geology, it's rocks. But like, it's half dome. It's shaped like a half. You ever wondered what happened to the other half? Where is the other half of Half Dome?
My guess it would like be in the ground or something.
I mean, it's not like, I mean, kind of yes, but it's if it were down there, you would see it, right?
Yeah.
So it did get removed. But obviously more than one thing has to have happened, right? Like, just falling off is one thing, but something else has to have happened to remove it. And so a lot of geological thinking is looking at something, and I apologize, I think I said obviously, and maybe it's not obvious, but I'm hoping by the end of the semester, those things will start to be. So a lot of geological thinking is looking at a picture and going, okay, there's this feature, this feature, this feature. I see Thomas said glaciers. Yeah, this is absolutely a glacier situation. This massive valley was carved out by glaciers. And so what happened with the other half of Half Dome is that, first of all, a glacier just kind of ripped it off. And then as the glacier melted and retreated, it, first of all, ground that other rock up and then moved it out of the valley. So, you know, a two-step process. It got removed and taken away. And so hopefully, as we look at more pictures of different things later in this class, you'll be able to go, okay, so in order for this and this and this, that and that and that has to have happened. So it's all about storytelling. Yeah, and the story of Yosemite is pretty much, well, it's not 100% glaciers, because really there's another step before that, in that these rocks have to have gotten there to begin with. You can't remove the rocks if they don't exist. So it's a story of we'll get there. We'll get there when we talk about Yosemite. I don't want to spoil it all now, nor do I want to spend our whole intro lecture on a really amazing place, but I don't want to get too carried away. But yeah, there's a story here. But sometimes it's actually less grandiose. Like, so this is, does anyone know where this is? This one is, I mean, it's a famous name, but it's not as known for its rocks. So this is actually at Laguna Beach. And so it's the kind of place people go to Laguna Beach because it's a beach and because it's famous for being a rich people beach, I guess. But it is, just look at these rocks. So what do you see about, so you see people doing beach things, going for a walk, you know, surfing, setting up their umbrellas, but look at the rocks around them. What do you notice?
They're round.
Yeah, so these guys down here are round, but are all of them round? Like, is this round up here?
It's all eroded.
Yeah, so this is kind of eroded out, but see, this is a cliff, and these are just rocks. So obviously, not everything is just a pile of rocks. This is in one situation, and this is in a different situation, right? You can see how this is a chunk. It's definitely eroding because you can see this is rounded off, but these are already totally detached. So you can go, okay, that stuff looks different than that stuff. And also, do you see the color difference here? I see very textured. Yeah, that wall in the back. You're right, Jade. It's super textured. Whoops. So see how these things in the front are kind of bluish, greenish, gray, and the things in the back are more reddish yellow? So color is actually a really important thing to look at. A lot of these things that sound really unscientific, like color, are actually a big indicator for a lot of things. But if you can go, okay, the stuff that's really chunky up here on this cliff is red and yellow, and the stuff that's really smooth down here and rounded is blue and green. And so you might be able to go, those are probably, well, they're definitely not the same stuff, because if they were the same stuff, they would be the same color. So two things have to have happened at least to put these two different kinds of rocks in the same place. But also just the fact that these are smooth and detached, and this is textured and kind of glommed together, maybe says there's different things, not just that made these rocks, but that is acting on them. And so very often geological thinking is going, okay, I see some rocks, but they're different from each other in these ways. What has to have happened to cause those differences? So a lot of it is looking at something and kind of doing detective work. In this case, we've just been doing it visually. A lot of times the chemistry and physics can come into detective work. Like if a rock has certain elements in it, it might have had something happen to it in a certain way. Or if a rock has certain kinds of marks or scratches on it, it has to have moved in a certain way. It's detective work. It's really piecing together stories. But even then, sometimes geology comes into our life in really mundane ways. So here we have the grapevine. I assume most of you have driven or been through the grapevine at some point if you go to CSUN. And so you might go, why does the 5 go there? I mean, it goes through a lot of really big mountains. Why did they put the freeway there and not somewhere else? And the answer to that is the shape of the mountains, because they had to get the freeway through there somehow. And blasting a tunnel through big mountains is dangerous, expensive, time-consuming. They just didn't want to do that. But in this case, they went, okay, where is the easiest path through this mountains? What is the shape of the freeway that can avoid going up anything super crazy and just weaving through it? And so that's engineering, but the engineering has to take the geology into account. The mountains are shaped that way for a certain reason. And actually, a lot of the reason for the grapevine being shaped the way it is the San Andreas Fault, which I hope most of you have heard of. If not, we're going to talk about that way at the end of the class. But yeah, that's because the San Andreas Fault is moving mountains past each other and happened to open up this spot that they could put a freeway in. So geology is everywhere. It shapes both the places we go to see the geology, like Yosemite or the Grand Canyon. It shapes the places we go for other things, just for natural beauty, like the beach. Or it just shapes our lifelines, like freeways, or water goes through here, electric lines go through here. A lot of our lifelines connecting SoCal to everywhere else follow these paths that are carved out by mountains moving and being formed in very specific ways. So geology shapes everything. And our daily interactions with the landscapes are also geology. So it's not just like we exist in this place, or I'm going to this place because it's pretty. But sometimes the landscape can fight back. Maybe fight is the wrong word. The landscape does stuff, and that influences us as we live here. This is from last year, but things like flooding, mudslides, and snow hit California roads in January of 2019. And so those things are weather. Flooding is weather, snow is weather, mudslide is when weather and geology interact. But in order to get these things, first of all, the shape of the land does affect the weather. The place, the location of the mountains and how high they are affect where warm and cold, wet and dry air can go. And so that affects where it's going to flood, where it's going to snow. But also a flood, if you have a steeper hill, more water is going to pour down it, and it's going to pool up more where you've got the lowest ground. So the shape of the land, shaped by the earth moving over time, affects where you get floods, where you get mudslides, the higher up the mountains, where you get snow. So even though a headline like this is just like, oh no, I hope I never have to drive again, that's all the geology causing this. So yeah, you can blame geology when you get stuck in the grapevine, usually, actually. Either yeah, or you can blame bad drivers, but it's all about the shape of the mountains in this case. Or sometimes in places that are not California, you can have really direct intrusions. So this is a headline from 2018. So does anyone remember this in 2018 when the volcanoes in Hawaii just flipped out? I see one person nodding. I see a few people nodding. Cool. I have to click through everyone. So yeah, it's basically Hawaii is 100% volcano. Hawaii would not exist if not for volcanoes, and we'll talk more about why. Oh, I see some yeses in there. Cool. So yeah, that is very much the land decided to split open and spew molten rock everywhere. By the way, Kilauea is Hawaiian for spewing. That's literally what that means. It's a really good name for a volcano. But yeah, this overran a lot of homes, and so this was a massive problem. Luckily, most people evacuated because volcanoes, unlike earthquakes, volcanoes give warning. Earthquakes really don't. But this is a way of geology causing a really profound impact on individual families and their livelihoods. All the while, in this case, people might be thinking that this is destruction. I mean, destroyed is in this headline. But this volcano is actively making brand new rock. The second this rock cools, it's the youngest rock on Earth. So it's destruction and creation at the same time. That's geology. Come on, slide. Geology has caused really bad problems here in the San Fernando Valley. So I'm going to stop asking if anyone was alive during the Northridge earthquake, because every time I ask that, I just feel old. But in 1994, January 17th, 1994, magnitude 6.7 earthquake hit. It's known as the Northridge earthquake, and because it caused really profound damage in Northridge. It damaged literally every single building on campus. It knocked down hospitals and apartment buildings, and this is the interchange of the 5 and the 14. And so this was this headline is actually from the day after the earthquake. It turned out to be a 6.7 that killed about 58 people. And that was just the Earth, which had been minding its own business for thousands of years, decided that it was time to let loose some stress and cause this really intense earthquake. And so this is the kind of thing that, people might go on not thinking about this. And then all of a sudden, it's a really big problem. So we'll talk more about the Northridge earthquake later on in this class, because actually, in addition to being extremely relevant to us here at CSUN, this is actually a really important earthquake for how we study earthquakes. It's really important for science if you can have a silver lining to it. But also worth noting, people weren't thinking a whole lot about earthquakes when this happened, but we actually have hundreds of earthquakes in California every week. So this map is the earthquakes in the last week as of 11 o'clock this morning. And you can see there were 1,337 earthquakes in California and Nevada in the last week. So the size of the box is the size of the earthquake. So most of these are magnitude 1 and 2, which is too small to feel. But some of them, the biggest is 4-ish. I know some people felt this one and this one. But this just shows the Earth is moving and changing and rearranging itself all the time. This is active geology in action. And actually, if you ever think you feel an earthquake, by the way, this is a map you can access. I'm gonna put the address for it in the chat box right now. So if you go there when you think you feel an earthquake, this map is something you can click on and see if you can find what you just felt. But yeah, we're in an active place. The Earth is doing what it's going to do, and we as humans, there's some things we can screw up royally, like fires or extracting natural resources. But some things like earthquakes, just they're the boss. We can't. They'll do what they're going to do, and we have to just build to live with it. So human interaction with geology is we're actually going to talk about that less than the processes that lead to those interactions. Like, we're not going to talk a huge amount about like how to engineer against earthquakes, although we have a whole other class, Geology 104, where we do talk about that. But we're going to talk about what makes those earthquakes happen to begin with. What made those mountains get there to begin with? Why is this area so prone to flooding? Why does Hawaii just split open and spew molten rock everywhere? We're going to get into the why and the how. So I know I'm talking and talking, but if you have a question at any time, like, you don't necessarily have to wait for me to stop. Before I go on, any questions so far? Okay, cool. I'll go on. So if it will let me advance the slide. Cool. So geology also has a lot of like practical and commercial applications. So a lot of jobs in geology. So you can be a geologist and you can be a teacher, you can be a researcher, you can really be someone who goes out there and like measures rocks and does science for the sake of science. There's a lot of application, like if you can be a geologist and be someone who studies hazard and advises people what is or isn't safe. There's also a lot of geology is in sort of commercial and industry. A lot of products and resources and things are very much geology jobs, like this, like gas. You know, why is gas where it is? Why is oil where it is? Why is coal where it is? These things are called fossil fuels, which might give you some hint. Fossil, where do they come from? You know, and where do you find the fossils that make this? So you need very specific materials, so chemistry, and conditions, so physics, to make these fossil fuels. And so that's a geology thing. We'll talk more about that in our sedimentary rocks unit. Or if you've ever been in a place where it said, oh, that's dangerous because of asbestos, or if you've ever been watching those like late night TV shows and they come in with the mesothelioma guy, so asbestos is something that is dangerous because if you breathe it in, it can give you cancer. But asbestos is a mineral. Asbestos is a geological product that happens to be very bad for you. But both the producing of and removal of asbestos is a geology thing, and it's very much an industry thing. Or if you like shiny rocks, so actually these are minerals, they're not strictly rocks, but if you're interested in gemstones and in, you know, whether just because you like to collect them or because you're interested in jewelry or art or whatever, and actually even if you're interested in paint, a lot of like paint comes from rock matter. Just finding things that are aesthetic or monetary, a lot of that is geology. You know, the dollar in the US is based on a gold standard, which comes from an amount of gold that's sitting in the treasury. That gold, most of it got mined out of California, which was in California because of really specific geological conditions. So all of that ties into geology. And even things like, California is really known for its wine, and that is even controlled by geology because, first of all, the shape of the land controls where what the weather is going to be like, which then can control what does or doesn't grow and how it does or doesn't age. But also different plants like to grow in different kinds of rocks. And so as it turns out, that combination of the shape of the land and the chemistry of the land, so the physics and the chemistry, allow really awesome wine grapes to grow here. So a lot of things tie into geology, even if you're not necessarily looking at a rock in any of these. And so again, this is a huge realm of geology, and I think a lot of people in the past when I've taught this have been like, oh, I didn't know that counted. That's a job that interests me. We're not going to get a lot of that into that sort of human usage stuff in this class, partly just for time, partly because in order to get into that stuff, you need to have the basics of how the physics and the chemistry work. And that's really what we're going to focus on in this class. But also the geography department has classes on this. And geography and geology are super closely related. But for some reason at CSUN, they're totally different departments and totally different colleges. And there have been some conflicts about who's allowed to teach what. So if you're interested in resources and use, that's in the geography department. But if you were looking for a job, it might be still a geology job. But yeah, geology is everywhere. It is a lot of things. And you know, even if you step back and think about it, like some stuff that I didn't even talk about, like again, your computer, the microchips, there's silicon. That's something that you mine out of the earth, which is geology. It's everywhere. So we would not be on Zoom if not for geology. But yeah, there's a lot. But again, this is a 15-week class, so we're going to do what we're going to do. But yeah, let's go back to this definition. So geology is the study of the earth, which is more than rocks. It's change, it's dynamic, it's physics and chemistry that affect where we live, that make our home planet what it is. Or if any of you are secretly here from another planet, because I feel like anything could happen in 2020, welcome, and you're gonna learn about the earth. But we're, you know, it's much more than this. So let's geologists do look at rocks. So I know I was just saying all of this. It's not rocks, it's everything. Rocks are just part of it. Geologists do spend a lot of time looking at rocks, but that's because those rocks are kind of like the history books that you're going to be reading to learn about what happened. So in any given rock, you kind of have encoded information about what made that rock form. And that encoded information might be in the shape of the rock, or the color of the rock, or whether it's smooth or cracked. Or if you can, like in this one, you can see there's the imprint of another rock in this one. It can give you information about how they formed, about what chemistry is there, what physics is there. There's also tests you can do to actually find out how old these rocks are. And so rocks are, you're analyzing them because they hold that information. And so what this class is going to do is give you the information to read the story that's in the rocks and then tell it back in a way that someone who might not be able to read rocks can do. So I guess you could almost call this a language class, but not really. Actually, a lot of the words in geology, by the way, are really, really, really literal, which is nice. A lot of them, like if you can't remember what something is called and you just describe it, that is often pretty close to correct. But yeah, rocks are the pieces of the puzzle to put together the story. So going back to this guy, yeah, you got that it looks kind of rough and crumbly and that it has specks of different material in it. And so we can already see that a bunch of stuff has to have happened to this to make that happen. There has to have been some situation where you could get chunks of different stuff in this larger rock. Something has to have happened to make it rough and crumbly. So you can learn a lot from just looking at an individual rock. But then putting it in the context of where it came from makes that story all the clearer and all the stronger. So this rock is from this area. So this is the Owens River Gorge in the Eastern Sierra. So it's kind of off 395 if you have ever driven up that way. And if you haven't, you totally should, because it's the gorgeous stretch of freeway. Oh shoot, pun not intended. That is the Owens River Gorge. It's gorgeous. Sorry, not that sorry. Sorry. But you got your rock climber here for scale. So this is, you know, in this spot, it's probably, you know, 50 to 80 feet, but in some places there's over 100 feet of this same kind of rock. And all of it came from one gigantic volcanic eruption about 760,000 years ago. So the Long Valley Caldera in Eastern California, which right now just looks kind of like a low grassy valley with a lake in it, is actually a gigantic volcano. It's the second largest volcano in North America. And it just blew the heck up and blanketed everything for hundreds of miles in a massive, massive layer of this stuff. And so you have chunks of different things in it because it wasn't just rock oozing out. It was everything got blown up and then kind of glommed back together. And so it's kind of rough also because a lot of this was really, really hot. And so it just consolidated in midair, because as soon as it hit the air is much colder than the inside of a volcano. So it cooled almost instantaneously and just into whatever chunky form that it was in, and then it kind of piled up. So we'll talk a lot more about this kind of thing and about that specific eruption in sort of the second month of this class when we talk about igneous rocks and volcanoes. But yeah, just looking at this, and again, once we talk about igneous rocks, you'd be able to look at this and go, yeah, that's definitely an igneous rock. It definitely started as hot and cooled down. But sometimes putting it in context really brings that story home. So like you could take a rock out of the Grand Canyon and probably learn a lot about, okay, this is a sedimentary rock. It formed in something that has to have been a sea. We know it was kind of this old, but then putting it in the context of the Grand Canyon can tell you the whole story. But at the same time, looking at the individual chunks can help you read the landscape. So really narrative, there's so much narrative, even though it's, it's physics and chemistry, it's narrative. So our definition for this class is geology is the study of the chemistry of the earth, the physics of the earth, the history of the earth, and what that means for the future of the earth. And we're going to be framing this around rocks because rocks can tell us about those things. So yeah, we're going to be looking at a lot of rocks. Yes, I'm going to ask you to be able to identify some rocks, but always with the purpose of knowing what those rocks can tell us about what made them get there and why the earth is the way it is. So this said, there's going to be sort of 4 major chunks of this class. So for the first few weeks, we're going to be talking about just the building blocks, the basic structural building blocks. So we're going to talk about the structure of the earth on Wednesday. Then we're going to talk about plate tectonics, which is the physics building blocks of the earth, the literal chunks of it that move around. And then we're going to talk about minerals, which are the chemical building blocks of the earth. All rocks are made of minerals. And then after that, we're going to have a section on igneous rocks and volcanoes, so the kind of rock and how they get there. And then sedimentary rocks and all kinds of different things that form them, so glaciers and rivers and landslides. So kind of rock, how they get there. And then we're going to end with metamorphic rocks, how they form and identifying them and what makes them be like that. So forming mountains, crashing continents into each other, having earthquakes. So it's really going to be, so it's not going to be like I'm going to make you memorize a bunch of rocks. You're never going to have to memorize a bunch of rocks just for the hell of it. You're going to be learning about the rocks to learn about their context. And so that's what we're going to do. And so that is my last slide before we go through the syllabus. We're gonna step through the syllabus in a minute. But does anyone have any questions or comments or just stuff you want to say before I switch over to that screen? Does anyone? Nobody has a hand up. I'm gonna switch screens, but if you think of something, just totally okay to speak up. Where is my share screen thing? Oh, come on.
Arthur?
Hello?
Yeah, you were talking about asbestos. Could you explain what asbestos does? Like what it's used for?
So it's mostly used as insulation. And wow, Zoom is not letting me change my screen sharing settings. So it's mostly used as insulation. And so it just because of its chemical properties, which we'll definitely talk about when we talk about minerals. It's just really good at sort of retaining heat. But the problem is because it's very fibrous, those fibers can just break loose and get in your lungs, and your lungs can't break them down. And so they can kind of be a nasty place to, they can just cause some real problems. Does that answer your question?
Yeah, thank you.
And we'll totally talk more about that. And also, anytime, I'm also always free to hang around a little bit after class. So if you have questions after class, definitely feel free to hang around and ask. Sometimes I might say, hey, can you hold on to that till the end of class, depending. But yeah, cool. Definitely okay to ask about stuff, just anything you're wondering. I am here to help you learn. But first, I guess we should at least go through the syllabus. So in the before times, I would have handed you a copy of this. Now it's on Canvas. Canvas and Zoom are going to be where everything is happening in this class. So if you cannot, I assume you access Canvas because that's where I put the code for the Zoom room. But if you're having trouble accessing it, please let me know, and I'll try, because I want to get that sorted out as soon as possible, because everything's going to be posted there. So the syllabus is up there now, but let's just step through it. So Geo 101, Monday and Wednesday from 2 to 3:15. And oh yeah, I guess I should introduce myself a little more first. So I'm Dr. Lozos. I've been teaching at CSUN since 2016. I've taught this is actually my second time teaching this class. But I've taught a lot of other classes, sort of introductory level classes. I teach a class called Geology Goes Hollywood, where we learn stuff through bad movies. I teach a class called Living with Earthquakes in California. But this is kind of the bigger picture. I teach an upper division gen ed called California Geology, if you're really interested in applying this stuff to California specifically. But when I am not teaching, so I am an earthquake physicist. So my research is focused on earthquakes. So actually this picture, my Zoom background right now is the fault that ripped open the surface in the earthquakes last summer in July of 2019. And I went out there a couple days after and helped measure some stuff, which was really exciting, even though it was like 109 degrees out there. And I was jet lagged because I'd been in Europe. It was an interesting weekend. But most of the time I study earthquakes by making fake earthquakes on my computer. So that's another side of geology, or actually I'm more of a geophysicist. I really focus on the physics, but I do computer simulations of earthquakes, because kind of sitting around and waiting for a real one is really not efficient. And also it's, if you're trying to understand hazard, it's kind of not good to be like, I can't help you until the hazard's happened already. So I do computer simulations. I try and go, okay, what could this earthquake be like before it actually happens? And so I do that when I'm not teaching, and when I'm not working at all. So you probably already saw my cat. The other one, I have another one who will definitely photobomb at some point, but she's sound asleep right now. I play a lot of music. I brew my own beer. A lot of geologists do that. I like to play Dungeons and Dragons. I do a lot of, I guess there's less time for that during the semester, but I figure I should try to be more than just some talking head screaming about how rocks are cool. But I mean, mostly I'm talking about how rocks are cool. But yeah, so that's me. And I actually, worth noting, I did not start as a geology major. So I've been doing this for a long time now, but I actually started as a music major. And then once I realized that what geology encompassed and how it was really just learning about what the earth does, I was just like, wait, that's really cool. And I ended up actually changing my mind late. So a lot of people, don't come into geology until later on, but it's just a thing to think about. But yeah, so that's me. Feel free to ask me other questions. But anyway, as for this class, so I'm your teacher. I'm sure a lot of you are taking 102 or taking the lab as well, but 101 and 102 are actually completely separate classes. So I can definitely help you with stuff for 102, but I'm not necessarily trying to link this directly with 102 just because they're technically separate classes. But they should help you with each other. But yeah, my office hours, they're going to be Tuesdays from 2 to 4 on Zoom. So they're on a separate Zoom meeting code from this one, because I have this one set up to record stuff and things, but that is stuff and things, articulate. I have a link to that other one on Canvas as well. And so, and if you can't come at that time, but still want to talk on Zoom rather than just emailing. August is asking, was 102 required? No, it's not. An undergrad degree at CSUN requires that you have a physical science lab class. And so taking 101 and 102 means they're related concepts, but you could take a geology class in a biology lab, or no, biology is separate. You could take a geology class in a chemistry lab, and so on. Oh yeah, books. We'll talk. Let's get on to books. well, actually, give me 1 second to finish talking about office hours. They will be every week. If you can't make that time, email me and we can set something up. I'm really flexible. So yeah, books now. So books, try to have them by next week. So we're not going to use it this week. And I figured it would be, yeah, so again, I apologize that books were not listed for this class until kind of the second week of this month. I wasn't originally going to be teaching this class this semester, but the other class I was supposed to teach didn't fill, and so they didn't tell me I was teaching this until the beginning of August, and so I wasn't able to say what book we were going to be using until then, so I'm really sorry about that. But yeah, the book we're going to be using is this one. It is Essentials of Geology by Stephen Marshak. I guess it's fading in and out of my screen here. And so this is the 6th edition that I have. The 5th edition is also totally fine. I think they it's really, most of the stuff that's different is in the climate change chapter, which we're not really going to be touching on because that's a whole other giant can of worms. Yes, climate change is real, and no, we can't talk about it in one day. Yeah, so this book, the bookstore should have this now. And they will have the 6th edition, and they will have the fancy bound version, which is, of course, the most expensive way you can get this. But there are cheaper ways to get this. You can order through Norton's website a version that basically they send you just a stack of papers with 3-hole punch in them that you can put in a binder, and that costs like maybe half as much. It costs a lot less. Also, you can find, and if you like ebooks, you can get an ebook of this for, again, about, I think it's less than the, so this new is, unfortunately, it's the cheapest geology textbook. They're all god-awful expensive. This is like $100. I think the punched out paper one is like 70. The ebook is like 55. And also it has a lot of exercises and stuff that you can do. But definitely there are a lot of used copies around, like absolutely check Amazon or whatever site you like for used copies. The 5th edition is going to cost you even less. When I looked earlier when I emailed you about the book earlier this summer, as in like a week ago, there were copies of the 5th edition for like $15. So definitely used is great. Ebook is fine, whatever works for you. I believe, I know that the library, the Oviatt library has some copies of this in the library, but I have no idea how that works with COVID. I don't know if they're like letting different people touch books. I guess I'll try and find that answer. But just because I assume most of you are not on campus and not around Northridge right now, having your own copy is good. Digital hard copy, 5th, 6th, doesn't matter. But yeah, I'm not going to assign you anything from this week. But definitely, if you can have it by next week, that'll be great. If you've ordered it and it sounds like you're not going to have it by next week, just get in touch with me and we'll figure something out. But we are going to be actually using this. So I encourage you strongly to do the reading of the relevant chapter before class. But a thing that I'm going to have before each sort of subtopic is there's going to be just like a quick little vocab matching exercise on Canvas. So it's basically going to have a bunch of definitions and a bunch of words, and you're going to match them. They shouldn't take very long. But those are going to be due before the lecture on that topic. So I'm not going to do one for Wednesday, but I will have one for next Monday when we start talking about the structure of the Earth. And so basically it'll require you to look through the book and match the word to the definition. And so you already have seen those words once. And then if you do the matching and read the chapter, you'll have already seen those words twice. So generally the more times you hear something, the better it sticks with you. And so that's sort of the purpose of these. None of them are going to be very long assignments. None of them are going to be like, they're meant to be extremely straightforward. They're just meant to get you familiar with the words and also give you some points. There'll be easy ways to get points. You'll be able to redo them until you get them right. So it'll just both get you some points and then put you in a better position to get points on the stuff that's graded more stringently. But yeah, just let me know about this if you can't get it by next week, and we'll figure something out. But yeah, so that's, and any book questions?
are our assignments based on the book, or is it going to be separate?
So most of the assignments are going to use the book. So I guess I can talk about the different kinds of assignments now. I think I listed them later. Yeah, so we'll jump ahead to where, so it's your grade is based on these things. So homework and quick quiz questions. So a lot of, like, you're going to have a bunch of those vocabulary matching things throughout the semester, and those are going to be directly based on the book. Then these quick quiz questions. I was thinking, oh, alliteration is fun, but then actually saying that out loud is kind of terrible. But quick quiz questions are going to be basically like 1 or 2 multiple questions before each lecture based on the last lecture. And so it's going to be like literally 1 or 2 questions. They're never going to be long quizzes. And so what those are going to be is just checking where you're at based on the last class. So the vocab questions will be before you hear a topic, and the quick quiz questions will be after you hear a topic. So it's kind of, the opener and then the main act and then kind of the epilogue, And so the way those quick quizzes are going to work is you're going to open it and you're going to have like 90 seconds to answer that question. And then once it's, and then that'll be due at 2 p.m. So it'll be due at the moment class starts. And then it'll tell you what the answer was. And so the purpose of that is just to give you, check what you retained. But the way those are going to be worth, so those are actually going to be worth 2 points each. So if you just do it at all, even if you get it wrong, you still get a point. But if you get it right, then you get 2 points. So they're, partly participation grade, partly just checking where you're at. Getting them wrong doesn't mean you're losing out a whole lot. And so there'll be one of the, starting next week, I'm not going to have one of these this week. And so those will be based sort of on, they'll be based on the lecture, which is tied in with the book. But for the vocabulary things, you're going to be using the book directly. And there's also going to be like a couple of other assignments that are throughout the semester that will benefit from the book. But the definitions in the vocab stuff are going to be directly out of the book. And some of the kinds of questions I asked you to think about might also be. But yeah, so those things are going to be a full half of your grade. And so a lot of that is just, if you do that stuff, you're in good shape. Then there's also going to be, so there are going to be 4 multiple choice tests, which I know sounds like a lot, but bear with me for a second. So there are 4, but you will drop the lowest one. So like, let's say you just really super don't understand metamorphic rocks and you get a really bad grade on that test, it just doesn't count. Or like, let's say your computer will not turn on and there's nothing you can do. Although I do recommend having like a plan B for logging in, like on your phone or on your tablet or at a friend's house. But like, let's say you can't connect at all and you miss a test. Doesn't matter. I will drop your lowest multiple choice test score, no questions asked. So, and the way those are going to work, there's 4 of them. They're going to be like 30 questions each, so they're not going to be a lot. And so on the 4 days that they're listed, we're going to start the class with a review session. So we're going to have half an hour to just, you can ask me anything you're uncertain about. And then starting at 2:30, you'll do the test and you'll have 45 minutes to do the multiple choice test. And so that's the way those are going to work. So you'll be able to ask any last second questions and then do that. And then the lowest score goes away. And so that's worth 30% of your grade. But again, if you're super on top of doing the reading and doing the vocab things and doing all the quick quizzes and actually looking at it to see what the right answer is. So it's not just going to be like, you're wrong, and not tell you anything. It'll actually say an explanation of the answer for the quick quizzes. And it'll also say what's right. So if you're good about like reading those and doing the vocab stuff and listening to lecture, then you're going to be in good shape for those. And then the last 20% of the grade is going to be an open notes written final. And so really I should actually say open world. So in this case, you'll be able to use your textbook. You'll be able to use your notes that you take in this class. You'll be able to use everything on Canvas. You'll be able to connect to the videos of our lectures. The only thing you won't be able to use is talking to each other or talking to other people. So communication with another person is off limits for the final. but every other resource you'll be able to use. And so the multiple choice tests, the questions will be pretty similar to the kind of thing on the quick quizzes. And then the final is going to be a lot more interpretive. Remember, I just went on this whole big thing about like, this is a story. We're telling a story about the earth that we're reading from the rocks. And so the final is going to be putting everything that we've learned into interpreting some things and giving some sort of geologic inference and opinion. And so that one you'll actually, it'll be due at the time our final ends, but you'll actually have like an entire day or two to do the final. But the multiple choice tests will be at that set time. So I know that was a roundabout way to answer your question about what the book is for, but are there any questions about assignments or what your grade is, or about the book?
So the assignments are due every Monday before class?
Oh, sorry. Yeah, so they'll be due at different times. So you'll have a quick quiz due probably every Monday and Wednesday starting next week. But they're going to be like literally one question, maybe two. So it's it should only take, I mean, they're timed. So they will literally take you, if it's a one question one, it'll take you 90 minutes. Or not 90 minutes, oh my gosh, 90 seconds. Wow. Yeah, so those will be, they're quick. So you'll have one of those pretty much every time. I'll get to you in just a second, Thomas. The vocab ones will be every couple of times. So it's not, so it'll always be due Monday or Wednesday. But depending on when we start a new topic, it'll depend on which one. So those will always be up on Canvas. I would get in the habit of checking Canvas every, you know, I wouldn't say maybe not every day, but like maybe check it on, like, so we have class on Monday and Wednesday. So I would check it again, like in the late afternoon on Monday and Wednesday, or you know, check it when you want to check it. There will be something there, but get in the habit of checking Canvas regularly. And I will keep it updated. I'll put everything there. So actuallyAll the quick quizzes will be on there, the vocab assignments, all the other assignments will be on there. I'll put what chapters to read on there, but also, I guess I'll go out of order in here again. So on the last page of the syllabus is our rough course schedule. And so when I said we're gonna have a new vocabulary thing every topic, this is kind of what I mean. So today we're on our introduction, what is geology? Next time, we're going to talk about some geologic time and key principles. So here this says chapter 10. Eventually read that. Don't worry about it too much. But you'll eventually read chapter 10. But I'm not going to do a vocab thing for Wednesday because I don't think most of you have the book yet. So you'd have a vocab thing before structure of the earth, a vocab thing before plate tectonics. But notice plate tectonics is 2 days. So you won't have another one until before minerals. Also worth noting is, so these list whole chapters, and some of these units sound like they might have a whole lot of chapters. Like the sedimentary rocks section here in the middle involves parts of 5 chapters, but you are not going to be responsible for everything in all 5 of those chapters. I mean, certainly reading the whole thing is helpful and it gives you a lot of information. But another thing I'm going to post with each topic on Canvas is something that, oh, can you see that? No, something that looks like this. So again, in the before times, I would hand out actual pieces of paper, but I'm going to be posting bullet points on Canvas for each new topic. And so these are kind of your note-taking guides. These are basically your study guides. So these are going to list the things that I'm expecting you to know from that chapter and that lecture. And so anything that isn't on that list, even if it's in the book, you don't necessarily need to worry about it. So that stuff will go up on Canvas. The list of which chapters will go up on Canvas. This course schedule is the last page of the syllabus that's already on Canvas. Notice we have a few days with no class. So September 7th is Labor Day, no class. October 12th is Indigenous Peoples Day, no class. I don't know if that's actually a school holiday, but there are no holidays in October, so I'm giving you that one off. No class on Veterans Day, and I'm not going to have you do class the day before Thanksgiving because that's just mean. This is on Canvas, and I'll also put sort of headers up as we go through the semester. So does that answer your question on that? Cool. Other stuff. Oh yeah, and I will be posting our lecture videos, but what I'm actually going to do is I'm going to put them on a YouTube channel. And so that's linked on the top of Canvas as well. And the reason I'm doing that rather than just directly uploading them to Canvas is that YouTube allows you to turn on closed captions immediately. If I were to, you can get stuff closed captioned through CSUN, but it takes them a little while to do it. So if I do it on YouTube, I can put the video up immediately and it can automatically caption it. It's probably going to mess up a few geology words, but I'm going to try to, those words will probably actually be on the slide. So I think you'll be okay, but if you're not, just email me. Definitely email me questions. And actually, let's talk about email since we're already super not going in order. Never feel bad about emailing me. It is always okay to contact me. It is never ever a bother, no matter how many questions you have. I'm here to help you learn, and I really want to do what I can to facilitate that. So never feel ashamed of asking. First of all, I'm sure, and also never feel ashamed of asking anything in here. For any question you have, I'm sure someone else has the same question. But also, for any time someone else has a question, there might be one where you're like, oh, I totally know that. So definitely never feel bad about asking stuff, but you can also email me at any time. But I do want to note, since the entire universe is online right now, and I am teaching 3 other classes, I do get a lot of email. So I will answer you as soon as I can. I'll answer stuff in the order that I get those messages, but please don't panic if it's not immediate. Like it might be a few hours, or if it's like Tuesday afternoon or Friday afternoon, which is the deadlines for my other class, it might not be until the next morning. I will do my best, but just don't panic. I will get to you. But that said, if it's been more than 36 hours, that might mean that my email software ate it. So if you have emailed me and it has not, if I haven't responded in 36 hours, please email me again. Please go, hey, Dr. Lozis, did you get my email? That's not a bother. I just might have actually lost it because Outlook kind of sucks, but it's what we use for faculty. We're not on Gmail like you guys. Also worth noting, if you email me on Friday night, I'm probably not going to answer you until Monday. But I also encourage you, if you can, to like build some personal time into the weekend if you're not doing that already. It's a lot harder to do work-life separation when you are online for everything. But yeah, but basically, yeah, I will get to you as soon as I can. And if it's been 36 hours, please email me again. Also, if something's broken, because Canvas always has something that fails. If something is broken, please send me a screenshot when you're telling me that something is broken, because it'll be a lot easier for me to fix it if I can see what the error is. With that in mind, Canvas works better with Firefox and Chrome. It really doesn't play nice with Safari or Internet Explorer. So most problems can be solved by using Firefox or Chrome. So any email questions? My email's at the top of the syllabus. You can also send me a message through Canvas. That's fine too. Okay, now that I'm totally going out of order, grading scale, simple 10-point scale, 9 to 100, 80 to 89. I don't generally do pluses and minuses unless someone is being really awesome or really awful. So like, let's say you have an 88, but you participate all the time and ask a lot of great questions and are really engaged. Then I might give you a B+, even though that's in the B range. Or like, let's say you have a 72 and you are obnoxious and tell people that they're wrong and are rude and are, constantly interrupting other people. I might give you a C-. I've only ever had that need to happen once, but generally it'll be this 10-point scale. And participating always helps. Like, the more you participate, the more I'm like, yes, that person is awesome. But again, like, there's no curves, there's no anything. I would love to be able to give you all A's. I'm not, if you all get 90 and above, I will give you all A's, and that would make me super happy. So it's just percentage based, and there will be a couple of extra credit opportunities as we get on into this course. So no curve, but yes, extra credit. So stay tuned for that. Late policy. For book-based stuff, you can turn stuff in late up to 5 days. Basically, you lose 20% of the score for every day that it's late. So that goes for the vocab stuff, the quick quizzes, basically anything that's not a test. But you can't take tests late. If you miss a test, you miss a test. But again, with the multiple choice tests, even if you accidentally miss one, you just drop it. But the final needs to be on time, but you'll have a longer amount of time to do it. So any questions about that? How are homework assignments going to work? So different ones are going to work in different ways. Definitely another thing that comes with checking Canvas, most of them really are going to be the quick quizzes and the vocab things, and they'll all have instructions written in them. But if there's something that's a little different, the instructions will be there. I'm never just going to be like, here you go, bye. But if you're not, so that's a reason to check Canvas often and make sure you've looked at something before it's due. But also, anytime you're not sure, just email me. Again, like never, I would much rather clarify something for you at the beginning than have you at the end of the class being like, I have no idea what's going on. Does that make sense? Cool. Okay, cool. So now that we're moving totally backwards, what have I not done? Okay, responsibilities. So log in your responsibilities. Log into class prepared. Be ready to pay attention, participate, ask questions, do the homework, do the reading. Being prepared is what it sounds like. Next is just respect people by being attentive. So there's a lot of distractions that come from taking Zoom classes. And so just find a way to put yourself in an environment where you can focus. And so whatever is comfortable for you, like if you would rather, be laying in your bed, petting your dog, like that's fine if that's a comfortable place that you can focus. I really just whatever is going to help you learn. But like if you're, maybe not being in the same room with roommates playing Super Smash Brothers, things like that. Just put it in the place where you can really focus and pay attention to each other. So again, keep yourself muted when you're not talking. I have you auto muted for now, but like, again, unmute when you do want to talk. And also I'd like it if at all possible, you could keep video on just because it feels, we're all socially distancing, but it feels like a little too distant when you're a bunch of like white text on a black screen. So actually seeing each other, makes it feel a little bit more like we're human beings sharing content and talking with each other. If you can't be on camera, like your camera doesn't work, it is what it is. But I really encourage that just so we can see each other, we can put a face to a voice, so I can see you and get to know you. So things like that. Then next, let me know if you can't turn something in on time. There's not always going to be an accommodation, but I can't make any accommodation if I don't know what's going on. So like as soon as something comes up, just let me know. And similarly, if you need any sort of accommodation, just let me know as soon as you can. Like I'm here to help, I'm glad to help, but I can't help if I don't know that I need to help. So just please let me know, one-on-one, email, whatever, just whatever makes you comfortable. And then my responsibilities to you, I'm here to help you learn. That is my job. I'm here to try and be as clear and helpful and hopefully enthusiastic about this material. I'm enthusiastic about it. I hope to make you enthusiastic about it. I'm just here to help you learn. I can't learn for you. I can't answer your question if I don't know that you have one. I can't, make an accommodation if I don't know that you need one. But I'm here to do what you need to help you learn. So just please, the more communication we have on both sides, the better shape we're all going to be in. I think that was everything now that we went out of order. This is just some boilerplate stuff I have to put in because the university requires it. So yeah, I'll be putting everything on Canvas. Right now, if you go on Canvas, there are two little things. One is just a quiz on basics of the syllabus to make sure you read everything. No time limit. You can answer it as many times until you get it right. And one of them is just a basic introduce yourself to me so I know who you all are, since I'm not going to ever meet most of you in person, probably. I'd like to get to know who's in my class and what you're excited and learning about. So with that, hopefully you can still hear me since there's a very loud noise outside. Are there any other questions real quick? All right, then I'm looking forward to working with you for the rest of the semester. We're done for today, so I'm going to hang out for a few more minutes if anyone wants to ask me something one-on-one, but if not, feel free to take off. That actually went longer than I thought. Sorry about that. And I will see you Wednesday.
Bye. Thank you, Professor.
Thank you, Professor.
Have a good one, everyone.
Thank you.
Bye.
Bye. The rest of you hanging out because you have questions, or? So you're still in here, Porfirio and Hassan. Want to ask something, or are you just kind of zoned out? All right, I'm gonna end the stream. Have a good one.